The ability of a conductor to allow free flow of electrons can be termed as conductance. It is the reciprocal of resistance, and unit was called mho, which is ohm spelled backwards. Symbol was inverted ohm sign. Conductance G is the inverse of resistance. If R is the resistance of a conductor, G is 1 by R mho. In the International System of Units SI, the unit of electric conductance is Siemens, represented by the symbol S. Siemens is also the unit for electric susceptance, reciprocal of reactance, and electric admittance, reciprocal of impedance, which were also represented by mho. Though the symbol is capital S, the name of the unit begins with lowercase letter s. It has been mentioned that SI term Siemens is used universally in science and often in electrical applications, while mho is still used in some electronic contexts. As discussed earlier, the property of a circuit or a component that opposes a change in current is inductance. Inductance is represented by L and the unit is Henry, H. Lower values are mentioned as millihenry and microhenry, which will be equal to 1 by 1000 Henry and 1 by million Henry respectively. Induction of a voltage within a coil by a change in electric current is known as self-inductance. When another coil is placed near it, the magnetic flux produced by the current in the first coil can induce an electromotive force in the second coil. This is called mutual inductance and is the principle by which a transformer works. Fraction of magnetic flux linking between the coils is the coefficient of coupling between the coils and is denoted by the letter K. Maximum linkage possible is 1 when all the flux lines in L1, the first coil, links with L2, the second coil. Higher coefficient of coupling occurs when the coils are very close to each other. High coupling induces more voltage in the second coil, while loose coupling or low coupling induces less voltage. When the coils are far apart to have no mutual inductance, then the coefficient of coupling will be 0. Transformers work by the principle of mutual inductance. If the number of turns in the primary winding of the transformer is N1 and the number of turns in the secondary winding is N2, then the ratio of voltages V1 by V2 will be equal to N1 by N2. If the number of turns in the primary is higher, it will act as a step-down transformer. When the number of turns in the primary is lower, it will act as a step-up transformer. Transformer works only on alternating current. If we want to step up direct current voltages, we have to first convert the direct current to pulsating current using an oscillator. Then a step-up transformer can be used to step up the voltage. Such a setup is often called an inverter and is commonly used in homes to provide alternate power supply from a large storage battery when the mains power fail. Inverter circuits are also built into uninterruptible power supply or UPS used for computers and other devices. Those devices generate high frequency alternating current in the process to reduce the size of the transformer needed. Switch mode power supplies for amateur radios also work on a similar principle. This is a simple step-down transformer commonly used in power supplies. There are two sets of windings. This is the primary winding and this is the secondary winding, that is the connections. Windings will be inside this and this will contain a laminated core for preventing eddy currents. That will be a ferromagnetic core in a transformer. Now I am measuring the primary voltage. Primary voltage is nothing but the supply voltage. That is 235 or 230 to 35 varying voltage, and the primary of the power supply. So that is the voltage which is coming to the primary winding. Now I am measuring the secondary voltage. That is, you can see that a pair of crocodile clips have been used to connect the secondary winding output to the multimeter, digital multimeter. And you can see that earlier I had measured in this setting, that is up to 750 volt setting, because line voltage is higher. And now I have changed it to this setting, 200 volt maximum setting, because I know that step down voltage will be lower. You can see that the step down voltage, the voltage in the secondary is only 9.9 volt. So this is the step down action of a transformer. So this transformer has stepped down from 230 to 9.9, approximately 10 volts. So the turns ratio in this transformer will correspond to that. The ratio of the turns will be like 230:10. Actual number of turns will not be 230, it will be much more, to have enough impedance to prevent too much of current damaging the primary winding, because depending on the thickness of the wire used, you will need higher number of turns.